The worst part with parametric equations so far and derivatives is taking a derivative after the first one. And it's not necessarily super bad, it's just there's a couple things that you need to remember. So the big thing that we have here is we have the derivative of y with respect to x, and that's what we found. That was the derivative of y with respect to t divided by the derivative of x with respect to t. When I do it again, I'm taking the derivative with respect to x again. So, some things that we need to do. We need to take the derivative that we found and take the derivative with respect to t again to find the second derivative. But in order to make sure that it is being with respect to x twice, we now need to divide it by the derivative of x with respect to t again. So, a lot of our steps are going to be the same. We need to find dy over dt, we need to find dx over dt, and we divide them. But then if I need to find a second derivative, I need to take the derivative of the derivative we found and divide it by dx over dt, which we found before. So, given the following parametric equation, x equals 3t squared, y equals 2t to the fourth minus 5, find dy over dx and find the second derivative of y with respect to x. So, the first thing we need to find is dy over dx. So we need to find dy over dt, dx over dt. Okay, well we have x right here, so let's do that one first. So we have the derivative of 3t squared, so 6t, and the derivative of 2t to the fourth minus 5, so 8t cubed, and we're leaving it at that. So the first one we need is dy over dx. We have dy, which is 8t cubed, divided by 6t. We can technically leave it just like this, but because we're finding a second derivative, we are going to be using this to kind of help us out. If I have to take the derivative of this, I'm going to use quotient rule to help us out, which is more work than I am willing to put in at this current moment. So we're going to simplify this to kind of help us out. 8 and 6 have 2 in common, so I'm going to factor out and simplify it down. So I have 4/3. T cubed divided by t is the same thing as t squared. So 8t cubed divided by 6t is the same thing as 4/3 t squared. So this is our first derivative. So now what we need to do is find the second derivative of y with respect to x. So we're going to take the derivative with respect to t of the thing we just found, so dy over dx, and divide it by dx over dt. So we want to take the derivative of this 4/3 t cubed. So 4/3 t cubed, or t squared, we're going to multiply by 2 and then bring it down. So we have 8/3 t. And we need to divide it by dx over dt, which is that 6t we found. That line is way too big. And then for the sake of what we have here, we're going to simplify it. So we have a t, and we're dividing it by a t, so those are going to divide out to make 1. So we have 8/3 divided by 6. 8/3 divided by 6 is the same thing as multiplying by the reciprocal, so 8/3 times 1/6. So I have 8 over 18, which is the same thing as 4 over 19. So the first derivative is not too bad. The second derivative, we have a little bit more that we need to think about. So the derivative of dy over dx, and we are dividing it by dx. And we have to do that because our functions are not with respect to the variable we're trying to take its derivative with. Yeah, so this is how we kind of account for that. So our last problem here is the parametric equation x equals tangent of t, y equals sine of t, and we want to find the second derivative at pi over 6. So we need dy over dt, we need dx over dt. Okay, y is sine of t, so I know the derivative of sine is cosine. Tangent of t, the derivative of tangent is secant squared t. We are going to use one specific fact about secant to kind of help us out here, but we're going to do that in a second. So we have dy over dx equals the derivative of y with respect to t, which was cosine of t, divided by the derivative of x with respect to t, which is secant squared. Secant squared is the same thing as, or secant is the same thing as 1 over cosine. So if we have 1 over secant, that's the same thing as cosine. So if I have secant squared in the denominator, that's the exact same thing as having cosine that we are now multiplying by. So we have cosine of t times cosine squared t. This is going to be cosine cubed t. Now that I've found dy over dx and simplified it as much as I possibly could, we're going to take the derivative of the numerator and divide it by what we have. So we need to take the derivative of this and divide it by this. So if I want to do that separately, I can. So d over dt of dy over dx. So the derivative of our thing here, so we have chain rule, we have cosine cubed, so we have 3 cosine squared of t times the derivative of cosine, which is negative sine. So d, the second derivative of y with respect to x, is going to be 3 cosine squared t times negative sine t, all divided by secant squared. And we also need to make sure that our variables match. So one of the things that you've probably noticed me doing a bunch is writing x instead of t. We have to make sure they match or else our answer is not right. Okay, so we're going to kind of move some stuff around. Secant squared is the same thing as cosine when it's in the denominator. So I have 3 cosine to the 4th times negative sine. I just forgot a variable altogether. Times negative sine t. Okay, so now what we're going to do is we are going to find the second derivative at a specific value. T is equal to pi over 6. So d to y over dx squared evaluated at t equals pi over 6. So I have 3 times cosine to the 4th of pi over 6 times negative sine of pi over 6. Pi over 6 is going to be a unit circle value. I'm just going to take out the 4th power really quick. I'm also going to move that negative to the front with the 3. Just in case, I don't want to forget it. Cosine of pi over 6 is going to be that 30-degree mark. So 30 degrees, we have an x value of the square root of 3 over 2, and we have a y value of 1/2. That square root of 3 over 2 is still being raised to the 4th power. So we have negative 3 times the square root of 3 to the 4th over 2 to the 4th. So square root of 3 over 2 to the 4th power is the same thing as the square root of 3 to the 4th divided by 2 to the 4th. Square root of 3 to the 4th is the same thing as saying square root of 3 squared and then having another one. Square root of 3 squared is the same thing as 3, so we have 3 times 3 divided by 2 to the 4th. So we have 9 over 2 to the 4th, so 2 times 2 times 2 times 2, which is going to give us 16. So we have 9/16 and 1/2. Okay, so we have 3 times 9/16 times 1/2. We know it's going to be negative. We have all of our even numbers on top, or on bottom, all of our odd numbers on bottom. So we have 9 times 3, which is negative 27, 16 times 2, which is 32. So a lot of the same things that we would do for derivatives before, we're going to do again. We just have to treat the second derivative and subsequent derivatives a little bit differently because of the fact that they are with respect to t, and our function, have variables of t to begin with.